California is becoming a global hotspot for next-generation polymers. In this first episode of Circular Tech Polymer Solutions, we explore 3 innovators based out of California that are reshaping the circular economy: FLO Materials, Novoloop, and Mango Materials. 3 companies, 3 technologies, 1 circular future. First up is FLO Materials. High-performance plastics such as thermosets and mixed material composites are some of the hardest materials to recycle. Once made, they typically end up in nature and landfills, because traditional recycling is generally a complicated, energy-intensive process and degrades their performance. FLO Materials, based in Santa Barbara, is pioneering ECANs, enamine covalent adaptable networks designed for true closed-loop recycling. It can be indefinitely recycled even from mixed waste streams with no loss of quality. They depolymerize at low temperatures, consume less energy, and require no expensive catalysts. FLO has demonstrated possibilities of ECANs across eyewear products, which can be made, unmade, and remade into materials with equivalent or higher performance. This bridges the long-standing gap between durability, performance, and recyclability. It enables FLO to represent a core pillar of recyclability in circular polymer innovation. Next is Novoloop. Polyethylene bags and films like shopping bags and packaging films are among the most problematic wastes on the planet. Only 4% ever get recycled. Novoloop, based in Menlo Park, created the ATOD process. Accelerated thermal oxidative decomposition. ATOD breaks down polyethylene waste into monomers and rebuilds them into polyols and thermoplastic polyurethane (TPU). Their flagship life-cycle TPU performs like virgin TPU but with up to 41% lower carbon emissions. Their second platform, Recycled Plus, upgrades TPU manufacturing scrap into higher performing materials. Now, if we look at its real impact and scale, Swiss brand On used life-cycle TPU in their Cloud Prime sneakers. In 2024, Novoloop completed a demonstration plant in India producing 70 tons per year of upcycled TPU. Further, in 2025, having partnered with Shanghai Hyde Science and Technology, they target 16,000 tons per year by 2028. Novoloop proves that the world's lowest value plastics can become premium performance materials, making them a circular pillar of upcycling. Next in our episode is the Mango Materials. They tackle the double challenge of utilization of greenhouse gas methane and the conventional plastic pollution challenge. Now, the difference between bio-based and biodegradable surely warrants a dedicated episode on its own. For today's episode, we're focusing on PHA. Mango Materials, based in Vacaville, uses methanotrophs, a methane-eating bacteria. It converts the waste methane into PHA, extracted and turned into YOPP pellets, which can be later used in various polymer products. YOPP fibers biodegrade in about 6 weeks in marine environments, and the entire cycle may even be carbon negative, capturing methane and making something biodegradable. At the Easterly Wastewater Treatment Plant in Vacaville, methane flows directly from anaerobic digesters into Mango's bioreactors. Their long-term vision is to establish decentralized PHA production hubs at wastewater and biogas facilities across the US, turning thousands of waste sites into local polymer factories. Mango's technology is already being tested or used in real products. YOPP fibers featured in Allbirds Moonshot shoes, the world's first net zero shoe. BioPP biopolymer used by Natura for their Biome line of sustainable soap boxes. Another example is their latest YOPP biodegradable sandbox toy set, which showcases the versatility of methane-derived PHA. Supported by Biomade and the US Department of Defense, Mango Materials demonstrates how biotechnology can create local, circular, climate-positive polymer systems, making them a circular pillar of biodegradability. 3 companies, 3 powerful pathways to circularity: recyclability, upcycling, biodegradability, and together they prove that the future of polymers isn't linear, it is circular. And this is only the beginning. Stay tuned for more innovations in the PolyMerge series, brought to you by Aether, the sustainability division of PolyNovel. And if this excites you about the future of circular materials, hit like, subscribe, and join us for upcoming episodes. And let us know in the comments, which breakthrough impressed you the most?